Okay, good afternoon. Do I have voice? Is the voice okay? Can you hear me? Any voice? Perfect. Thank you, Kevin. Thank you, Bradley. We'll have to start now. Unfortunately, again, a couple of people are missing. If you're listening to the recording, please try to make these classes. By attending these classes live, it proves to me. So when I'm marking your assignments and your assessments, I am more confident that your assignment will be of more more reliable. It gives me that confidence that your assignment is accurate and reliable. So I'm just being a little bit what's the word? I'm being a little bit giving you a little bit of a hint here. Attend the classes. It will improve your results for your assignments. Okay, now let's look into this lecture this week. Well, not really lecture, but a description of what some of the topics are. So we're going to have a look a little bit about the services of at the data link layer. We will talk about where is the data link layer implemented. A little bit about the data link error control, multiple access links and protocols. I think we've had a bit of a discussion about this before, but I just want to double check something really quickly because something looks interesting here. I just want to make sure that I'm not going over this again. Nope, that looks good. It looks like we're in the. Okay, I'm just gonna mute the mic for a bit. Give me 1 second. I'll be back. Okay, apologies for that. Yeah, I think last week I went over the details of the assessment, and I missed a little bit about we were supposed to do IP addressing last week. So what I'll do is I'll talk about layer 2 and layer 3 today at the same time. But let's talk about layer 2 first. So this includes a switch network, vulnerability identification, and we're going to talk about. So this is a separate little section. So that's not layer 2 stuff. That's another topic. So this is layer 2, and then we'll talk about layer 3 at the end of this and where that fits in. Now I do have an image that I would like to share with you all. If I can get this one. Where are we? I'm just going to copy an image. I'm going to give this to you if I can. Hopefully it works. Nope, it won't work. All right. What I might do is I'll get you guys to do a screenshot of this. If you can take a screenshot of this, okay? And the reason why I'm saying this is because this is quite useful, this diagram here. So these are all the protocols at the different layers. At the data link, we're looking at Ethernet, which is the most common and most popular connection out there. This is just your cable, your cabling, which could include a copper cable and can also include fiber optics as well. This is included as Ethernet. These ones, so this is the FDDI, that's your fiber optic cables. These ones you don't really have to worry about these days because they're old stuff, right? Really, really old. In fact, I think that has something to do with the telephone network, I believe. And the point-to-point networks, they're old school. They are really old school and no one uses them anymore, so don't worry about that too much. Okay, so we're really talking about Ethernet here. So data link layer is the protocols and control of putting those zeros and ones on some sort of physical media. So putting it on a cable or a fiber or wireless. You're probably thinking, well, wireless is not physical. Well, the air, the environment, that's a physical medium. If believe it or not, even light has physical particles to it. So everything has that. If something can go through something, then that's what we're talking about. That's what we mean. Data link layer will put that onto the physical layer. Really, technically, these should be the same layer. In fact, IP version 4, it is TCP/IP protocol. It is the one they do combine that into the one layer. Okay, so let's get into this. At the data link layer, we encapsulate network layers. So I've got an IP packet. This is an IP packet. In the IP packet, I will have the source, destination, IP addresses, and other stuff, right? When the layer 3 gives this packet, so this is a packet. That's a packet. We put it inside, kind of like those Russian dolls, those boxes within the box. In fact, I got a delivery the other day from Amazon. It was this huge box, and inside it was just a smaller box. But what's happening with the layer 3 packets? They are encapsulated. They are put into a frame. The frame is what gets transmitted at the layer 3. Okay. The addressing scheme will be called a MAC address, and a MAC address is a medium access control. So your Ethernet card, network interface card, by the way, is a NIC. You might have two NICs on your computer. You might also have a wireless adapter. That means you have 3 physical addresses on your computer. So your computer does not have a physical address, or even your computer does not even have an IP address. It is your network interface cards that have the physical and an IP address. So what happens here is your MAC address is going to have an a MAC address. Your NIC, your network interface card, will have a MAC address, and it would look like something like this. Something, I've forgotten what it looks like. I'll have to double check this. Look like that. It'll have, this is hexadecimal. So each one of these is each one of these characters is 4 bits. And what's a bit? It's either a 0 or a 1. So we'll have 4 of those. So that is 4, 8, 12. 12 times 3 is 38. I think I'm missing one set. I'm just going to double check. So it's 48 bits, so we're missing one set. Okay, so that's 4, 8, 12. 12 times 4 equals 48. Okay, beautiful. So we've got 48 bits. The first half of the MAC address belongs to the vendor. So it could be Cisco, it could be Intel, because they make MAC addresses. It could be Gigabyte, what do you call it? Yeah, Gigabyte. It could be Lenovo, IBM, HP. They will buy from the same people that give out IP addresses. They will say, look, this 24-bit address is yours. And the rest of the stuff, you can put any number you like on this. Okay? And this is how it will work. Let me just get my other whiteboard. This is kind of important. So it doesn't really matter, to be honest, what MAC address you have, as long as on that network, it's unique. Okay? So say, for example, say, for example, Intel makes a MAC address, a network interface card, and you are given a MAC address of A, B. So that's the hang on a sec. Okay, so that's Intel's, and I'm just making this up, by the way. That's not Intel's identifier. But say it gives that NIC, that physical NIC that's on your computer now. That's the address. If you have another MAC address with exactly the same MAC address, sorry, if you've got another NIC with exactly the same MAC address, you've got a problem. The odds for that happening is incredibly unlikely. Even if someone, say like in another country, they make exactly the same, that you know how they steal designs and they steal network cards. Maybe someone is even spoofing the MAC address. It's very unlikely that you're going to get the same MAC address on a network. So if I've got lots of computers and we have a switch here, it doesn't matter what MAC address they have on these computers, so long as they're different. Maybe that's CCC 1, 2, 3, A, B, 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 and etc. Even if they're somewhere else on the world, it doesn't matter. As long as on this local area network, these MAC addresses are different. Okay, that's really important. And the odds is incredibly unlikely on the same network. You're going to get two MAC addresses with the same, two NICs with the same MAC address. Okay, now if we go back to this here, all right, now let's have a look at, so we've talked about MAC addresses already. We've talked about NICs. The switches is the networking device that operates at the layer 2 area. And this is what happens in a switch. So let's get a switch up and running. So this is a device with a few ports on it. We're going to do this nice and simple. Actually, I've got one here. I'll show you. I've actually just bought one today because I'm doing some wiring in my house. I'm wiring my house for some IP cameras, stuff like that. Actually, I'll give you a quick look. Okay, I'm not sure if you can see the camera, but I'm doing some wiring at the moment. I haven't finished it yet, but I'm connecting. I've got some IP cameras outside that I'm installing. So yeah, just doing a bit of wiring. Now this here is a switch. It's a ubiquity switch. It has power over Ethernet. But this can only work in my local area network. If I need to go to, if I'm sending something to you guys, it has to go through a router, a layer 3 device. This is only a layer 2. It's a great device. It's really, really good, high quality, has power over Ethernet. It's going to power my IP, cameras and my wireless access points. But it's only designed to communicate or allow devices on a local area network to communicate with each other. And this is how it works. There will be a table here, kind of like a database. When I learned it as a CAM table. It's a special type of memory. It is fast, expensive, but very fast memory. And in this table, it's a database of MAC addresses linking to the ports numbers. So if that's port 1, that's port 2, that's port 3, that's port 4. Okay? Now, I've got a laptop here. The MAC address is A, B, C, and then D. So now the MAC address, so this computer, this laptop, once it is connected to port 1, port 4 is a server of some type. And the MAC address for this server is 1, 2. By the way, if these were the MAC addresses on the network, these would be legitimate, by the way. These would work. So 111, 222, 333, 444. So now this laptop says it needs to send something to this server. The switch just starts up in the morning. It doesn't know anything. It's empty. There's nothing in this table. So we're going to create this. We're going to put the port numbers here. We'll put MAC addresses on that side. So when this laptop sends a request to shout out on the local area network, where are you, server? Where are you? This is what happens. The switch looks at the MAC address, puts that MAC address in here straight away. That's CCC DDD. Yeah, I know my rank's terrible. And it came through port 1. Okay, it will send that traffic. It's called a broadcast at all of these ports. Now, there's nothing connected to these ports, so that it stays there. But it will not broadcast that frame back out the original ports. It won't send it back out. Okay, but it will put it in the database. Now, the broadcast gets sent out 4, and the server says, "Yeah, that's me. That you're looking for me. Here I am." It will return back that information back to this laptop. When it does that, the CAM table or the MAC address table will say, "Okay, great. Port 4 has this MAC address: 123 222 333 444." That's how it builds it. So now this laptop will say, "Great, I know where you are. I'm gonna send it to the switch." The switch looks at that table again and it just sends it out. Doesn't need to broadcast it anymore. It knows exactly where it's going. So that's how a switch works. But if you need to send it out to another network, you will need a router for that. And that router will be connected to that port, for example. Okay? Just remember, a router operates on layer 3 and with an IP address. If we only had network addresses in the world, we never had the internet, just local area networks, we won't need IP addresses. We would not need a router. But I mean, that's not going to be a really good network, to be honest. It's only a small little network. We need IP addresses and routers. Okay. There are some types of error control. Sometimes the little zeros and ones that go transmitted come across this, they're malformed, they're not really working properly. If a frame enters the switch and it's not quite right, it drops it and discards it. It may have some error controls on that as well. They could be lost or corrupted. So the retransmission usually happens at the TCP level. The TCP level usually takes care of that. Now, this is interesting. Multiple access links and protocols. Which means, yeah, it's pretty much, all right. I'm actually surprised that we were talking about this. I'm not going to put it in my next notes, but I'm also tell you, because it's something that we don't have to worry about anymore. In the old days, we used to have a hub. A hub did not have a CAM table or a MAC addressor table. What would happen always, all the time, it would, if something went in that way, and we had other ports there, it would send that traffic out anyway, except from that one. So what that meant was that these devices, that server and that computer, could transmit at the same time, and if it did, it would have a collision. So it needed a protocol called collision domain multiple access. Collision detection multiple access. Don't worry about this too much because we don't have hubs anymore. We only have switches. So we'll ignore that. But back in the day in the hubs, we used to look after, we used to need to know that a lot. Okay, so there's that switch. We already talked about the switch. Switches are a smart way. They deliver frames to each node that are connected to each port. They use MAC addresses. This is better than hubs because hubs just sent it out everywhere without thinking about it. And the performance is better. Now, and each port has its own collision domain. In other words, there's no collisions, okay? It has a collision domain. So if you have a hub in the old days, there you go. Anything that's connected to it is a collision domain. But with a switch, each port is its own collision domain. So that is your collision domain right there. There's only one switch, one port to one computer. There's no collisions there. It's only one-to-one. Now, here's something interesting about switches, though. We can do something called VLANs on switches. And this is how VLANs work. We get a switch. Say we are in human resources. And say we've got the sales team over here. That's two switches, okay? There are two different teams, okay? They're connected to two different laptops or computers, two sets of computers. Connection there, connection there, connection there. Same here. So two physical devices. They are air-gapped. I can't transfer anything I can't transfer anything from there because it's not connected. It's simply not connected, right? Okay. We understand that. It's easy. Nothing scandalous or nothing mysterious about this. Two separate devices cannot talk to each other. There's just nothing there to connect to each other with. We can do something like this by using one switch and separating that one switch. This is one physical switch, okay? By separating it into two virtual LANs. That will be VLAN. That VLAN is VLAN Human Resources. This is VLAN Sales. So that's connected to a laptop in the sales department. And that's another one. And that over here is connected to Human Resources computers. And maybe there's a server there, maybe a printer. They cannot communicate with each other. Just look at that device as two separate devices. They're still the same physical device, but we've divided them into virtual LANs. Okay. Now, if we wanted to connect these two together, which we can't do at the moment, we would have to use another port. Okay, I'm just going to put this port here. I'm going to have to send this to a router. And I will need to set up a trunk, which carries, so this trunk carries the two VLANs. It'll carry the VLAN Human Resources and the VLAN Sales traffic. So then I can go there and it will send it back there. But they are on different networks too. So that'll be on the, say, 0.1 network, and that will be on the 192.6.0.2 network. Sorry. Let me just fix that. That's on the 2 network. Okay, so they're separate VLANs. They have to, the only way that they work is that they have to be on different VLANs. Oh, sorry, they have to go through a router. Okay, that's called router on the stick, by the way, real name. Or even better, we can use, this might be a bit confusing. We can use a switch and we'll give it advanced features. We'll call it a layer 3 switch, which means that we'll have the two VLANs, VLAN HR and VLAN Sales, and we'll have a router inside. The router is inside. Switch. So this switch can perform some layer 3. You can even use router protocols like OSPF and EIGRP router rip. It's a very clever layer 3 switch. It does more. It will not replace a router, but it does some routing functions. A lot more to it than that, but that's just a bit of a quick rundown. Now, switches do have a vulnerability. And the biggest vulnerability of a switch, when I install this switch on my network, from a box, all I do is put the power into the power outlet, and it will start switching straight away out of the box. It will just start doing its job. And without me even being able to configure it, it'll start switching straight away. That's the vulnerability. Switches were invented at a time where security was not thought about that much. Okay, so there are some vulnerabilities in switches which we can mitigate. One of an issue is MAC address spoofing. So with the MAC addresses, they're usually burnt into a network interface card. Like when I mean burnt in, they're programmed, they're hard coded into a physical chip. But we can spoof that, and spoof means that I can. Here, let me see if I can draw this diagram here for you. I know my handwriting is terrible, but so say we've got a switch here. Okay, and it's connected to a DHCP server with a MAC address of 111.222.333.444, and we've got a computer over here with a MAC address of AAA, BBB, CCC, DDD. This laptop is trying to find an IP address. So it shouts out, says, hey, who can give me an IP address? Now this DHCP would usually respond and say, yeah, I can do it. No problems, I got you, man. But what if I happen to bring in a laptop with Kali Linux on it? A Kali Linux is a penetration testing device, operating system that has MAC spoofing. So it's listening, saying, oh, okay, you've got a MAC address of 111.222.333.444. How about I grab that MAC address, and when this laptop broadcasts through the switch, by the way, this is a switch, by the way. That's a switch, this box here with ports, and that's connected to the Kali Linux. This laptop has been listening to this traffic, and it notices that the DHCP server has the MAC address. That Kali Linux will say, you know what I'm going to do? I'm going to pretend that I have that MAC address, that it belongs to me. So it will send out that MAC address as if it belongs to this machine, and it will say, look, yeah, I'm a DHCP server. That's my MAC address. Here you go. It will trick the laptop, and the DHCP won't even know what's going on. That is called that is a MAC spoofing attack. The way to mitigate that is on this switch, we prevent these ports from having the ability to have DHCP traffic on them. Only that one can have DHCP traffic. That's the only way we can stop that. Well, there's another couple of ways, but that's the best way. So there's ways to mitigate against that. Yeah, so that's an address resolution protocol, falsified app message attack. So it's the same kind of thing as MAC address spoofing. We can do a man-in-the-middle attack or an on-path attack, they call it nowadays. And basically, with that last example that I had before, this Kali Linux machine now receives the traffic from the DHCP server, for example, or any other machine, grabs the traffic, and then allows it to go on to the laptop, right? Why? Because it can inspect all that traffic. A common attack, if you're at McDonald's or Starbucks or at the airport, especially at the airport, happens there all the time, and it's illegal. And people can get in big trouble at the airport if they do that, especially after customs. But what happens is the wireless network, the wireless router, or the wireless access points gives network or internet to people connected with wireless devices like mobile phones, laptops. What would happen is there will be a rogue wireless access point. Someone will have their laptop giving everyone a wireless access. All the internet, all the network connections go to that laptop, and then it sends the traffic to the access points at the airport or at McDonald's or Starbucks or whatever. All your traffic is going through this laptop, and the person on the laptop, just tapping away, recording all that information. So that's why when you're especially if you're in another country, don't use wireless internet. Don't use public wireless. Not the hotel, not the airport, not the cafe. Some countries don't have they're not strict on those type of laws. We need internet. So what you do is when you go to a new country, you get a SIM card, get a burner phone, a really really cheap mobile phone, like $100, that you can carry around with you and share that mobile phone internet while you're in that other country, and just share your proper phone. You piggyback off that burner phone, and that phone, if someone steals it, well, $100 is a lot of money, but iPhones are like 2,000 or secondhand like 1,200, so $100 or whatever. But you don't use public wireless anywhere, not even in Australia, to be honest. If you have to, then use a VPN if you have to use public network, because if that man in the middle attack or that on path attack, at least it's going to be encrypted. Now, VLAN hopping is interesting. Remember how I showed you this diagram of the VLANs before? Up here, with this trunk. If a hacker is able to break into this port and send traffic, it wants to go into VLAN sales, but it can't because there's a brick wall there. Unless they somehow manipulate the traffic that goes through the trunk. If they can do that, then they are performing a VLAN hopping attack. Okay, it's very hard to pull off, but it can be done. That's a VLAN hopping attack. And the way to defeat that is you're going to need a firewall. You'll need a way to prevent in any way of, I mean, it's going to have to go through the router. So you'll need to protect that router. Maybe you build an access list or a firewall or something like that inside that, or maybe put a firewall between that router and that switch. All right, so now this is another topic. This is a different topic now. We've moved away from layer 2 switches. There are, if you want to go, and unfortunately, I really wanted to show you this, but I just remembered that I was running Nessus, which is a vulnerability scanner. It scans my whole network and looks for vulnerabilities. But I remembered that I just reformatted my hard drive, and I don't have Nessus anymore on this system. But basically what it does is, with my own permission, okay, this is the blue team. This is my organization. I'm allowed to do this. I am using Nessus, which is a open source. It's free, not open source, sorry. It's free for like, I don't know, maybe 5 or 10 IP addresses. But what it does is it probes your network. It looks at your servers, your PCs, your computer, and it tries to find vulnerabilities in there. OpenVAS is open source, and there's Qualys. I was never able to pronounce that. But it scans your systems, your host systems, for known vulnerabilities. And it will tell you that, it will say, you've got a vulnerability here. Telnet is open, SSH is here. You have an FTP server and there's no encryption, there's no username and password. What's wrong with you? It tells you. It doesn't say that because that's rude, but it'll provide that information. You can use penetration testing frameworks like Kali Linux. Kali Linux is a pen testing operating system. So it's a Linux Ubuntu Debian, sorry, not Ubuntu, a Debian-based Linux operating system that is designed to attack system. It has penetration testing tools on it. You need to go and get this Kali Linux and play around with it. Like, you should do it today. It's a good tool. And while you've got that Kali Linux, you get another virtual, that's a virtual machine there, and you get another machine called Metasploitable. Now, this virtual machine on purpose has very, 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 very bad vulnerabilities. Okay, so you do that so you can practice your pen testing skills. On the Kali Linux itself, so this is Metasploitable. You know, it's exploitable. So you use a tool inside Kali Linux called Metasploit, and that tests, and you run scans and you probe and you do some pen testing. Don't worry about that. We're not worried about that. It's nothing to do with us. All right. Any questions? How for the people that are in this room at the moment, how is your assignment going? Does anyone have any questions about your assignments? Bradley or Kevin or Kai Huang, any issues with the assignments so far? It's a great exercise, one of my favorites. Yeah, Kevin, go have a shot. Read, watch the last week's what do you call it? Collaboration that I should be there ready for you to watch. If not, I'll do that today. But it is fun. It is one of my favorite assignments. It's a lot of fun. It's some interesting stuff there. But reach out to me. Send me a. It's probably a good idea. So put it in the discussion group if you have a question. If I don't get back to you in, say, like a couple of hours, even though we're supposed to get back to you within 48 hours, if it's like a couple of hours and I haven't responded, can you just email me, please? Because when it comes to the assignments, I want to get back to you really quickly, okay? So if you have a question on the assignments, put it in the discussion group, but wait an hour or so and then email me so I can answer quickly. Yeah, it is the activities in Immersive Lab, that it's pretty much the same, really. All right. Now, you guys all have me on. You all have me on Discord. On Discord, I'm pretty much on Discord 24 hours a day. So if you need something like urgent right now, in Discord, I can respond to you right now. Okay. So, but I still want you to use the discussion board so that other students can benefit from it. But you can reach out to me on Discord and say, Harry, could you look? I just sent you something in the discussion group. Reach me on Discord. So I'm just going to put my Discord link again. So please join. It means that I can reach out to you really quickly. But definitely, you still need to use the discussion board. Okay. No, thank you very much, Kevin. Appreciate it. That'll be really good. That'll be awesome. Okay. Well, that's all I've got for you today. Good luck with your assignments, and please let me know next Wednesday. I'll do a little bit on IP addressing because we kind of missed it last week a bit. All right, everyone, have an amazing evening, and I'll see you next week. Thank you very much. I'm going to end the recording now.